So, for a progress report, we've got the UptimeSV team back here so that we can see where they're up to. Welcome to the stage, Dean Little.
G'day everyone, I'm Dean from UptimeSV. We are a distributed network intelligence platform powered by Bitcoin. And because today is more aimed at developers, instead of just going full shill mode, I'm going to treat this more like a bit of a story of building on Bitcoin, lessons learned, problems that we faced, and some of the solutions that we're proposing that people can use so that you guys can use them in your businesses and your projects as well. So a very brief introduction. I've been a developer for over 15 years. I started my first business when I was 14 as a software development company, and I never looked back. I started out in Bitcoin. I really liked the idea. However, unfortunately, it was quite hamstrung and wasn't really useful for anything other than moving around large amounts of liquidity on exchanges. I then went on to do a bunch of other projects on different blockchains with my company. And helping out those projects, I racked up 50 million transactions, and I really enjoyed the process of building. However, I hated everything else about it. I hated the politics. I hated that they were not a stable foundation where a couple of people can just tell you how you have to run your business. I hated that many of them are like Ponzi schemes. And as someone who's been building businesses for a very long time, I can tell you that that's not what you really want to build something that's going to last on. And then someone answered our prayers, and they released this white paper. Actually, it came out 10 years ago, but some people decided to finally actually build it, and that was BitcoinSV. And so that's why I choose BitcoinSV, because it finally allowed me to build the things that I want to build on Bitcoin. But not only that, right, we finally have this stable protocol where they're not going to rip the carpet out from under you. It scales. We have the lowest fees imaginable, right? This creates amazing new opportunities with like money mobility, where I can pay the tiniest microtransactions to someone on the other side of the world, which currently, until very recently, like that has not even been possible. It's honest. It's not a Ponzi scheme, right? It's not give me money to build my shitcoin. It's you work, you test your ideas on the market, and you get rewarded for it. And thus, it's also subject to market forces. We allow miners to decide, which means we allow the market to decide. We allow the consumers, the users, to decide because miners have a profit motive. And most importantly, it's proof of work. And this is more than just the means by which we achieve Nakamoto consensus. Proof of work is a mindset. It's the idea of you exerting effort to generate value and being valued for it. Now, a little bit about UptimeSV. We're a couple of mates. We've been into Bitcoin for quite a few years. Very excited watching everything that went down with the hard fork, and we saw the prospectus, and we're just like, yeah, this is great. We're gonna build on this. Hackathon came up, and we went, great, this is our chance. So we threw together a really basic app over a weekend, accidentally won a hackathon on the other side of the world, and stumbled across a fairly lucrative business model with over 500 signups to our beta program. For those of you who aren't fully familiar with what UptimeSV is, it's crowdsourced network intelligence. So the problem with network intelligence platforms these days is if I were to ask the big players like Amazon or Microsoft, is my website offline? And they said yes, they're probably right. But if I asked them, is my website online? And they said yes, that does not mean anything. Because they're running enterprise-grade servers in an enterprise-grade data center with enterprise-grade internet, enterprise-grade DNS. This is not what your users are running, right? Not only that, there's a lot of, as you can see recently in the world, a lot of geopolitical unrest and a lot of problems with internet censorship. And if you're building a business, you need to know if you're offline and where and why. Is it ISP level? Is it national? Is it regional? So what we do is we enable enterprise customers to set up monitors on their web services, and then we pay real people, real users who download our app on their phone or their computer, a very, very small fee to perform uptime tests so that they can tell these enterprise customers how their services are doing. So to give you a little bit of an update on the progress, we won the hackathon in May. We then went, oh crap, a lot of people actually like this, we better actually build a proper business. So we got to work straight away in June We launched our beta sign-up in July and got over 500 sign-ups in about a month and a half. In September 2019, we attended CambrianSV. We completely rebranded everything to our new branding, and we completed the early release mobile and desktop Node apps. Now, coming into October, we're finalizing the server code and the enterprise dashboard, so nearly there. Now, because what we need to do is to send people money, no matter where they are, filter the data to make sure that they're honest, and spam a lot of data to the blockchain really, really quickly, the three main hurdles we came up against are address resolution, spam, which is controversial, but I'll go into it, and UTXO management. So the first hurdle was address resolution. The problem is when we were coming into this, there was one handles, there was cache handles, there was P2P, there's P2PKH addresses, there's P2SH, which we don't want people to use, and then finally came PayMail. So there's all these different standards of addressing. So we just thought, why not just have like one API, so you can just put in like any address and just pull out somewhere you can send money. So we created Polynym. This is an interim solution. Obviously, we believe in the future that a lot of this stuff will become more standardized, but there's already a whole ton of apps using this today. It's just a really simple way to handle the addressing problem. So we did it. You don't have to. You're welcome. You can find that at polynym.io or github.com/uptimesv/polynym. The second problem was spam. Now, this is controversial. I want to make it very clear. There's no such thing as a spam transaction in Bitcoin. Anyone who thinks that they are damaging Bitcoin by spamming transactions is a useful idiot who is paying miners to make our currency better. So thank you. Spam harder. But there is certain types of spam that are annoying, such as op return spam, right? Because it's an open protocol, it's subject to tragedy of the commons, right? It's difficult to maintain the cleanliness of these spaces, shall we say. And so what you find is if you don't have the best security practices and you're not like constantly filtering everything out, someone could very easily spam some really fire memes. And I'm sure you've all seen that go down. There's also another type of spam, which, clicker's not working. Next slide. P2P broadcast network spam. Now, this is something that's not well understood. P2P in Bitcoin is I create a transaction, right? Peer-to-peer transactions. I create a transaction, I sign it, I give that to you, you publish it, right? That's peer-to-peer transactions. But this is something different. It's the peer-to-peer broadcast network. This is the network that miners maintain for free because they want to receive new transactions. They want these transactions to propagate so that they have a chance of mining them to earn money. The problem is, if we were to move into, say, gigabyte blocks, right? The burden on the network actually increases by the number of transactions to the number of nodes. And if these nodes aren't necessarily miners and the things that they're spamming to this network aren't necessarily making money, at a certain point, this is going to compete with miners getting new transactions propagated to them. So we wanted to come up with a way that we could solve both of these problems. Just to give you an idea of the perspective of miners, right? There was like a conversation. When there are 10 gigabyte blocks, how are people going to get this amount of data in an efficient way, in a reasonable amount of time? And in one of the Chinese groups that I'm in WeChat, Lin Jiaming had this to say: never underestimate the bandwidth of a truck full of hard drives speeding down a highway, right? This is the sort of scale that I want everyone to be thinking about. We need to break the 1 megabyte mindset and start thinking like, oh, things are going to be like this big, right? Maybe not today, maybe not tomorrow, but it's coming. And so we need to plan for that. And so that's why we've created something that we call Unplanaria. Now, this is not a knock on Unwriter. We love Unwriter. Unwriter is amazing. However, it's a play on the way that his solution has solved this. So instead of going wallet, miner, node, right, where this node here is reading every message and then filtering on the server side and taking up a lot of bandwidth from miners unnecessarily, right? We can do this with the BIP270 model, but for apps, where I have a wallet, I create a transaction, I send this transaction directly to Twetch, say. Twetch can then take the data from my outputs directly without having to download all of these messages and scan the blockchain for it and store it locally in its own local database, which people can also access if they want to provide this as open data. They then publish this to the miner, and the miner gives them a confirmation. Now, another amazing thing about this is, until now, right, for like the last 10 years, we've only really used sig#_all, right, because it's the only thing that's been really secure for us to use. But if you change to this peer-to-peer model, it also unlocks the use of sig# anyone can pay, meaning you can put a set of signed outputs, like let's say a Twetch, to their server, and then someone can go and do a sig#_none, meaning they just sign the inputs and no outputs, and Twetch can go, all right, we'll put this together, right? So someone's posted a Twetch without paying, we put it on our site, someone likes it, that data has been valued, we can put the 2 and 2 together, boom. We can publish that to the blockchain to pay for that Twetch being published. So the user wouldn't even have to have Bitcoin to get into Bitcoin, right? These are things that have been in Bitcoin for 10 years, and until we have things like miner ID, BIP270, peer-to-peer transactions, they've not been possible. But now it's possible. And not only is this incredibly efficient in terms of its network footprint, it's also horizontally scalable. You can just add more servers, and it will continue to work. And it protects your Merkle proofs, because you're dealing in raw transactions and not a destructured transaction object. Now, the third hurdle that we came up against is writing a lot of data to the blockchain really, really quickly in rapid succession. And by the way, Unplanaria will be released shortly. We're just doing a few tests. We've got a couple of people using it. And yeah, I'll release that shortly. You can check it out on our GitHub. And also follow us on Twitter later. So UTXO management, the third thing. The problem with a lot of the stuff that we're doing now is we're using things like BitIndex, like wonderful services like this, but we're having to send like an HTTP request each time, and with DataPay, an HTTP request each time to get our UTXOs, right? What we can actually do is it's far more efficient. We're calling this data push. This is our solution for publishing huge amounts to the blockchain really quickly. So we have a single unique top-up address which you send your data to, you send your Bitcoin to. It tops up a bunch of X-proof threads, and then it generates a bunch of UTXOs and addresses. And then what it can do is it can chain them. So it can create a chain of 25 transactions. It can publish them, we're hoping, to an actual payment channel for a miner. And the miner can help you to package and broadcast those transactions. It handles all your thread balancing. It handles your ancestor limit, etc. And if you want to like reset your ancestor limit, like this is a way more efficient way of doing it, right? Like come February, we won't care, it won't matter. But if you're building now, this is going to be like really great for you, because all you have to do is check if the 25th or the 24th or whatever the youngest child is accepted into a block, and you know that all of its parents have also been accepted, because it can't be spent if the output doesn't exist. So we're basically trying to take the whole concept of like data pay. We're still using things like BitIndex and stuff like that, but we're trying to decrease the number of HTTP requests as much as possible and handle all the UTXO management locally, so that you can have really, really efficient transaction creation and write a lot of data really, really quick. And again, that's coming shortly too. That will be on our GitHub. We'll be releasing this as a free tool for everyone to use. Now I get to shill a little bit of the hard work that we've put into our actual business. So we rebuilt our entire mobile app since the hackathon. We found that the way we had done some things worked really well on a really small scale, but when you want to have thousands of users querying websites, you want to make sure that that doesn't accidentally turn into a DDoS attack. And so we've rebuilt a lot of stuff. We've changed our branding and everything. So now you can just sign in with whatever your handle is. You start your node. You can choose whether you'd like dark mode or light mode. You can choose if you want to use cellular data, because if you're doing something like load testing and the websites are really huge, it might use a lot of your data. We currently support English, Chinese, Japanese, and I believe we'll also support Korean after this in our locales. And we'll support a variety of currencies so that you can see how much you've earned. We also have a desktop application. Again, the same thing. We'll be supporting Windows, Mac OS, and Ubuntu, as well as Android and iOS for the mobile app. This is the dashboard, so it enables enterprise customers to sign in. They can set up a monitor. They can say where they want to track it and how often. They can set positive and negative filters, so they can say like Oceania minus Australia. If you had like a tropical storm and you wanted to see like if some of these like smaller countries in the Pacific were knocked out, you could do that. And then once you've set up your monitors, you can just see the health of your services. You can color code them, so it's very convenient and easy for the enterprise to see, am I online or not? Now, to answer the question that we've been receiving for the last 4 months, and I get it, guys, you want to use it, but it's a really difficult problem, and we've been working really hard on it. So please just be a little more patient. But we're aiming for a October 30th private beta release, so end of this month. If you would like to be a part of the private beta with the other 500 people who have signed up, please go to UptimeSV.com and register your interest there. With that said, guys, thank you very much for listening to me today. You can find us all on Twitter or Twitch. And if you're a company who's looking for uptime testing or has some ideas or wants to have some more ideas about how we can help your business, please feel free to come up to me after this or contact us however suits you. Thank you very much, everyone.